Welcome to homework.
Welcome back to another cross product problem. This time we're looking at what happens if we want to find the distance from a point, let's call it P, to a plane. We know we can define a plane by three different points. Let's call these Q, R, and S. And so if we define a couple of vectors, let's say A between Q and R, B between Q and S, and say C between Q and our point, then what we can do is try and figure out the distance from the point to the plane using some things that we know about triple products. Specifically, the volume of the triple product of the parallelepiped between A, B, and C is defined as the magnitude of A cross B times the magnitude of C cosine theta. And so rearranging this a little bit, if we write C dot A cross B divided by the magnitude of A cross B, then this is going to be the magnitude of C, it's the length of that vector C, times cosine theta, where theta is the angle between our vector and perpendicular. This is theta right here. Now, since cosine theta is adjacent over hypotenuse, that means the length of this perpendicular line, the distance from the point to the plane, is going to be the magnitude of C times cosine theta. So we can use this if we want to calculate the distance from, say, point P, 214, to the plane divided by Q, R, and S. In order to do that, first we need to calculate the vectors defining the plane. So A is QR, R minus Q, 0 minus 1, 2 minus 0, 0 minus 0, and QS, that's S minus Q, so again 0 minus 1, 0 minus 0, 3 minus 0. We'll also need C, that's the vector QP. P minus Q is 2 minus 1, 1 minus 0, 4 minus 0. So if we want to calculate the magnitude of C dot A cross B, we can do that in one step using our triple product. If we plug in C, A, and B into our matrix here. I'll point out this isn't the only way we can do this, but we'll talk about another way in just a second. So let's plug in 1, 1, 4, negative 1, 2, 0, and negative 1, 0, 3. And using the formula from our textbook, remember we ignore the first column and look at 2 times 3 minus 0 times 0. That's going to be 6 minus 0. And normally we would multiply by I. We're actually going to multiply by 1. Minus, then we ignore the second column, negative 1 times 3 minus 0 times negative 1. Negative 3 minus 0 times not j, but times 1 again. Plus, and then we ignore the third column, negative 1 times 0 minus 2 times negative 1 will be 0 minus negative 2, which is 0 plus 2 times 4. And since we don't have any i's, j's, or k's, this is not a vector, but just a number. 6 times 1 minus negative 3, that's plus 3 times 1 plus 2 times 4. And so we're looking at 6 plus 3 plus 8 is 17. The other thing we need from our formula, remember, is the magnitude of A cross B. And so we can get that by calculating the cross product of A and B. Once again, we're looking at 6 minus 0, I, minus negative 3 minus 0, j plus 0 minus -2, k, giving us the vector 6, 3, 2. If we want to calculate the magnitude of A cross B, that'll just be the magnitude of 6, 3, 2, which is the square root of 6 squared plus 3 squared plus 2 squared, or the square root of 36 plus 9 plus 4, and that's the square root of 49, or just 7. Since we determined that the distance is the ratio of the two numbers that we just found, we get the distance is, let's go back to that cross product, or the triple product with 17 over 7. I said earlier this wasn't the only way we could have found this. Since we already know the cross product A cross B, we could have found the magnitude of that and then found the magnitude of C dot A cross B just using the vector C and a dot product. So that would avoid having to do the cross product twice. Thanks for watching.